Today we're going to be looking at a special kind of integral. And before we do that, we're just going to look back a little bit to something we did in differentiation. When we had a function like this, a composite function, when we differentiated, what we did was we worked from the outside in. So we multiplied by the power, leaving the bracket as it is, reduced the power by 1, and then we multiplied by the derivative of what's inside the bracket. So in this case, I would think what happens when I differentiate 2x minus 3, and I get 2. And so I combine the 2 and the 4, so I'll get 8 times 2x minus 3 cubed. Now today, we're going to be trying to undo this type of thing by integrating. So let's have a little look at how we might get back to the original function. So we've got 8, we're going to increase the power by 1 because we're integrating, and we're going to divide by that new power. Now if I divide the 8 by the 4, I'm still going to have 2 here, so I've got 2 lots of 2x minus 3 to the power of 4. Now I started with 1 lot of 2x minus 3 to the power of 4, so I'm needing to divide by 2 somewhere. And the reason for that is up here, I multiplied by 2, which was the derivative of inside the bracket. So here, I'm going to be dividing by 2, because 2 is the derivative of what's inside the bracket. Now I'm already dividing by 4, so if I divide by 2 as well, what happens is the 2 goes down there, which will give me 8 divided by 8, they'll cancel out. And so I will be left with 2x minus 3 to the power of 4 plus c. So the rule that we're going to be using today is when we integrate a function that looks like this, we will do our normal integration on the outside of the bracket, so we increase the power by 1, divide by the new power. But we will also divide by the derivative of the inside of the bracket. A bit like what we did with trig yesterday. So let's go to our examples in the book. First example, we're integrating x plus 4 to the power of 7. So we're going to leave the bracket as it is. We're going to increase the power by 1, divide by the new power, and then we're going to check for the derivative of what's inside the bracket. I've got x plus 4. If I differentiate x, I get 1. If I differentiate 4, I get nothing. So the derivative of this is 1. I'm dividing by 1. Do you know what? I don't need to write that because dividing by 1 is just itself. So I'm going to leave the 1 out, but I am going to remember my plus c. Now remember that this answer is fine, but I can also write that as 1/8 of x plus 4 to the power of 8. For our second example, we've got 2x plus 3 squared. So we're going to leave the bracket as it is, and we're going to increase the power by 1, divide by the new power. Now we're going to check if we differentiate what's inside the bracket. Well, if we differentiate 2x, we get 2. If we differentiate the 3, we get 0. So I've got 2 as the derivative of this bracket, and I want to divide by 2. Now I'm already dividing by 3, so if I divide by 3 and then divide by 2, it's the same as dividing by 6. I'm putting a plus c. And remember, I can bring this to the front, so it can be 1/6 of 2x plus 3 cubed, or you can leave the 6 underneath. Both are absolutely fine. The third example isn't as obvious immediately. We need to do some preparation before we can integrate. So I'm keeping my integration sign because I'm not yet going to integrate. I just want to find a different way of saying this. So what I want is everything that's on the bottom, I want to be shifted to the top. So So I'm going to put it all in a bracket, this 5x plus 9. And on the bottom it's a cube root, which is the power of a third. It's on the bottom at the moment, so if I want to bring it to the top, I need to make it negative. Now I can integrate. So I'm keeping the bracket the same. I'm increasing the power by 1. Negative 1/3 plus 3/3 gives me 2/3. I'm going to divide by that new power. I'm looking for the derivative of what's inside the bracket. If I differentiate 5x plus 9, I'll get 5. That also goes on the bottom. Now I'm going to tidy this up. So on the bottom, I've got 2/3 multiplied by 5, and that's 10/3. Dividing by 10/3 is the same as multiplying by 3/10. In my bracket, I've got 5x plus 9. It's to the power of 2/3. The third tells me it's a third root, and the 2 tells me it's squared. Now there are a couple more examples, but we're going to do them together in class. So that's all the examples for today. Now the rules we've been learning today are based on our integration knowledge. So we increase the power by 1 and we divide by the new power. The additional part today is that we then also divide by the derivative of what's inside the bracket. Now I know that you will be taking this on okay today, and we're going to practice it in class. So the questions I'm asking you today are more about the kind of arithmetical things that we're likely to come across in these types of examples. So can you please tell me, if I divide by 1/2, what's that the same as? If I divide by 7/4 and then also divide by 3, what am I actually multiplying by? Because remember, I don't want a fraction under a fraction. I want to show what I'm multiplying by. And what is 1 more than -1/3? We will finish the examples in class and then we'll start the exercise together.